So we want to write the canonical form for this second order partial differential equation. And we are going to do that using the steps that I wrote down here. We are going to go through the steps to help us write the canonical form for this second order partial differential equation. So with the steps, the first one says check the classification of the PDE. And we can do that using what the discriminant. So we know that the discriminant is given as what? B squared minus 4AC. So from here, we can say that our A is the coefficient of what? UXX, that is 1. Our B is the coefficient of UXY, that is 6. And then our C is the coefficient of UYY, that is minus 16. So once we have them, we plug them into the discriminant to see what we are going to get. So we have B squared. So we are going to get 6 all squared minus 4. Our A is what? 1 times what? Minus 16. This is giving us what? This is 36. And then we have minus this, and that will give us what? Positive. So we have what? 4 times 16 will give us what? 64. And this is giving us what? 100. And since the discriminant is greater than 0, so you can see that the discriminant is greater than what? 0. We can say that this particular equation is an hyperbolic equation. Now, once you know or we check the classification of the PDE, you move on to the second step, which says that write the characteristics equation and solve for the characteristics variable, then set them to the and the eta. So you know that the characteristics equation is given as what? dy dx So what we are going to do here is to plug in our a, b, and then c from the equation that was given. You know that the discriminant is equal to what? 100, right? So we have our b. Our b is what? 6. So we are going to have 6 plus or minus square root of what? The discriminant is 100, which is this one. So we have 100 all over 2a. Our a is what? 1. So from here, we can say that our dy dx is equal to, this is going to give us 6 plus, let's put them into the positive and the negative. So we are taking the positive first. 6 plus root of 100 will give us 10 all over 2 times 1 will give us what? 2. Then we have dy dx is equal to 6. Then we are taking the minus 10 all over what? 2. So from here you can see our dy dx is equal to what? 16 divided by 2 give us what? 8. Or we have our dy dx is equal to 6 minus 10 will give us what? Minus 4 divided by 2, and that is what? Minus 2. So what we are going to do here is to solve for the characteristic variable by what? Integrating both sides. We are going to integrate this side. We integrate this side. So when we integrate dy dx, we are going to get what? Y is equal to, when we integrate 8 with respect to s, we get what? 8x plus the constant c. Let's make c the subject. So we are going to have c is equal to y minus what? 8x. Now from here we set this one to Zaya. So we have our Zaya is equal to what? Y minus 8x. Then we move on to this side. So we are also going to integrate, let's rewrite it, well, dy dx is equal to minus 2. So we are going to integrate both sides. We integrate both sides. So when we integrate both sides here, we are going to get y is equal to negative 2x plus what? The constant c. Let's make c the subject. So we have our c. C is equal to y plus what? 2x. Now once we have this, we set the constant to what we call eta. Since we have that here, we set the constant of the solution to what? Eta. So we said our eta will be equal to y plus 2x. So once we have this, we take the partial derivative of xi with respect to x and then with respect to y. So we have our xi x. When we differentiate this function with respect to x, any function of y or any y term become a constant. Then whenever we differentiate a constant, we get over 0. So this is going to give us 0, and then we'll be left with what? 8 here. Then we move on to xi y. We differentiate this function with respect to what? Y. Any x term becomes what? A constant. And whenever we differentiate a constant, we get 0. So the whole of this term will give us 0. And then we differentiate y with respect to y, we get 1. Then we move on to eta x. When we differentiate this eta with respect to x, we are going to get this will give us 0, this will give us 2. We differentiate eta with respect to y. Any x term becomes a constant, so this gives us 0 and this gives us what? 1. Now once you have this, you move on to the next step, which is what? Transform or compute for the expression for uxx, uxy, and then uyy. So you are going to compute for uxx, the expression for uxx, uxy, and then uyy. We are going to transform this into the xi and the eta. So before we can find uxx, then we need to find ux. Okay, before we can find uxy, uyy, we have to find uy. So first we are going to find ux and then uy. Okay, so we know that ux, that is the first partial derivative of the function u with respect to x going through xi. Going through what? Xi. We are going to get u xi x plus u eta x. Then we have our uy is equal to u xi y plus u eta y. So from here, when we plug them, we know that xi x is what? Xi x is minus 8. So we are going to get minus 8 u xi. And then eta x is what? 2. So when we plug it here, we are going to get plus 2u eta. Then we move on to this side. Xi y is 1. 1 times u xi will give us what? U xi. Then eta y is also 1. When we plug it here, we are going to get what? Plus u eta. Ux and uy, which is this and this, and I am putting it down here. We can proceed to find our uxx and then uxy. So we are starting with our uxx. And in finding our uxx, we are going to follow the diagram that I drew on the board to make it easy for us to find the uxx and the uxy and so on. So this is the diagram that is going to help us find uxx. So first you have to find your ux and then uy. Then you base on ux and uy to find your uxx using the diagram here. Very, very easy. So we have uxx. Now since we have uxx, we are going to base on ux. This ux to help us find what? Uxx. So with ux, the expression for ux, we have minus 8 u xi plus 2 u eta. So we have our minus 8, which is the constant. Then what do we do again? We find the expression for u xi. So this is u xi. We can obtain the expression for u xi using this diagram. So this is how we do it. We have u xi. We are taking it with respect to x. Take note. So we have u xi x. Then you come and write it. U xi. Then we have what? Xi x. So we have xi x. Since we have another x here, on u xi, we have to move to that very part as well. So we have u xi eta. U xi eta. Then we have eta x. Eta x. So we are done with u xi, move on to what? U eta. So we have plus, and then we have 2. We are also going to find the expression for u eta. expression for what? U eta using the diagram here. So this is U eta. So how do you find the expression for U eta? Going through the same steps. So we are going to move it in this direction. U eta Zaya. So we have U eta Zaya. We have what? Zaya x, because we are taking it with respect to x. So we move on to the x part. So we have what? Zaya x. Then we have plus. We have another x here, so we can find that one as well. So we have U eta eta, U eta eta. Then we have eta x, eta x. So from here, let's do some small simplification here. This is going to give us minus 8 U Zaya 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 x plus, sorry, so minus, we have minus 8 U Zaya eta eta x plus, this is also going to give us 2 U Zaya eta Zaya x. Eta is Zaya, we can write it as Zaya eta. Then we have plus 2 U eta 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 x. From here, you know that Zaya x is what? Zaya x is minus 8. So you can plug it here. So minus 8 times this minus 8 will give us what? Positive 64 U Zaya Zaya. Then we have minus again. Eta x is what? Eta x is 2. So 2 times minus 8 will give us what? Minus 16 U Zaya eta. Then we have plus. Zaya x is what? Minus 8. Minus 8 times 2 will give us what? Minus 16, right? We have minus 16 U Zaya eta. Then eta x is what? 2. 2 times 2 give us what? 4. So we have 4 U eta eta. Let's simplify further. So we have 64 U Zaya Zaya. This is going to give us minus 32 U Zaya eta plus 4 U eta eta. So this means that the expression for UXX, so we have UXX is equal to what? 64 U Zaya Zaya minus 32 U Zaya eta plus 4 U eta eta. Then we want to find the expression for UXY. So UXY, we have UX here. So you can use the expression for what? UX to find our UXY. But we are going to take the derivative with respect to y. So with this side, we are going to move to the y column. So we are taking the expression for UX because we have UX here. So we have minus 8. Then look for the expression for U Zaya with respect to y. So this is U Zaya, and we are going to move to the y column. So we have U Zaya Zaya, U Zaya Zaya. Then move to the y part, Zaya y. So we have Zaya y. Then we have plus U Zaya eta, U Zaya eta. Move to the y part, eta y. We have another one here, so 2. We have 2 U eta. So this is eta, and we are going to take it with respect to y. So we have to move to the y part. So we have U eta Zaya, U eta Zaya. Then move to Zaya y, Zaya y plus U eta eta, U eta eta, eta y, eta y. So from here, you can do some small simplification here. This is going to give us minus 8 U Zaya Zaya, Zaya y minus 8 U Zaya eta, eta y plus this is going to give us 2 U Zaya eta, Zaya y plus this, and that will give us 2 U eta eta, eta y. We know that Zaya y is 1. So 1 times this will give us minus 8 u Zaya Zaya. Eta y is 1. So we have minus 8 u Zaya eta. Zaya y is 1. So we have plus 2 u Zaya eta. Then plus eta y is also 1. So we have plus 2 u eta eta. So we have minus 8 u Zaya Zaya. This and that will give us minus 6 u Zaya eta. Then we have a plus 2u eta eta. So it means that the expression for uxy is the whole of this. So let me write it here. Uxy. We have minus 8 Now that we are done with uxy, move on to uyy. So we have uyy, the second partial derivative with respect to y going through there. We have uy here, so we are going to make use of the expression for uy. So the first one is u Zaya. So how do you get the expression for u Zaya? So this is u Zaya. But remember, we are taking it with respect to y. So we're moving to the y part, right? So we have u Zaya Zaya. So we have u Zaya Zaya. Then we have Zaya y. Then we have plus u Zaya eta. U Zaya eta. Then we have eta y. We also have u eta. So you have to move to the u eta diagram to find the expression for u eta. So we have u eta Zaya. U eta Zaya. We move to the y part, Zaya y. Then we have another y here, so we have to move that. U eta eta. U eta eta. Then we have eta y. So for me, let's do, I think this one, there's no need for expansion and simplification. What we are going to do is to plug in this. You know that Zaya y, this Zaya y is what? 1. So 1 times u Zaya, we have u Zaya Zaya. And then we have eta y is also 1. So it is going to give us u Zaya eta. Zaya y is still 1. So we are going to get plus u Zaya eta. And then we have what? Eta y is still 1. So we have u eta eta. Further simplification, we can add this together. So we have u Zaya Zaya plus 2u Zaya eta plus u eta eta. So our uyy is equal to what? Good. Now that we have our uyy, uxy, uss, what we are going to do? What are you going to do with the next step? The next step is to substitute this into the equation that was given. So we are going to plug in the expression for uxs, usy, and uyy into that particular equation. Then we have the next one is 6 u Zaya uxy, 6 uxy. So we have the constant 6 multiplying uxy. So we have the expression for uxy, which is this. We are going to write it there. Then move on to the last one, minus 16 uyy. We have minus 16. Then we write the expression for uyy. Uyy is what this. So we have is equal to what? 0. Good. So from here we have to do some small expansion to remove the bracket. So we have our 64. And then when we expand 6 times 8 will give us what? As negative 48 u Zaya Zaya. 6 times 6 will give us what? 36. So we have 36 u Zaya eta. 6 times 2 will give us what? 12 u eta eta. Now let's expand this bracket as well. So we have minus 16 times this will give us 16 u Zaya Zaya minus 16 times 2 will give us 32 u Zaya Eta. This will give us minus 16 u Eta Eta is equal to what? 0. So from here, let's do some grouping if to see some of the terms can cancel out. Let's start with u Zaya Zaya. So we have 64 u Zaya Zaya. We have another negative 48 u Zaya Zaya. Then we have minus 16 u Zaya Zaya. Then let's move on to the Eta Eta. We have 4 u Eta Eta. We have plus 12 u Eta Eta. Then we have minus 16 u Eta Eta. Then move on to the Zaya Eta. We have minus 32 u Zaya Eta. Then we have minus 36 u Zaya Eta. Then we have minus 32 u Zaya Eta. All of this is equal to 0. So from here, we have 64 u Zaya Zaya. This will give us what? Minus 64, right? U Zaya Zaya. We also have Eta Eta. This will give us 16 u Eta Eta. Then we have minus 16 u Eta Eta. Then we have 32, 36, 32. What are you getting? You are getting minus 100 u Zaya Eta. All of this is equal to what? 0. So from here we can see that some of the terms can cancel. You can see that this will cancel this. You can also see that this will cancel this. We are left with what? Minus 100 u Zaya Eta is equal to 0. Let's divide both sides by minus 100 minus 100. So this and that will go. So finally we have our u Zaya Eta is equal to what? 0. And this becomes the canonical form of the PDE that was given. Very easy.